Welcome to the next installment of my video lecture series in economics. And in this particular video lecture, I'm taking a look at monopoly profit maximization. And as always, when we talk about profit maximization, profit maximizing condition is where marginal cost is equal to marginal revenue. The thing I want you to understand when we're talking about monopoly is how that it varies from perfect competition. In perfect competition, remember, the market set the price. Price was equal to the demand curve, and price was equal to marginal revenue. So in a perfectly competitive marketplace, marginal revenue is constant. That does not hold for a monopolist. A monopolist is the sole seller of a product. Therefore, it faces a downward sloping demand curve, and it has a distinct marginal revenue curve associated with that downward sloping demand curve. So realize that a monopolist, when it adjusts output, it's also changing price because it faces a downward sloping demand curve. So for perfect competition, price was fixed. Firms alter output in order to maximize profits. In monopoly, firms jointly set price and output in order to maximize profits. So make sure you're comfortable with that distinction between perfect competition and monopoly. So this graph right here gives you that example, or gives an example for that. Here is perfect competition. We have a competitive firm. The demand curve is horizontal, and that price is equal to marginal revenue. And if I increase output by 1 unit, marginal revenue will be equivalent to the price. Because as my output increases by 1 unit, I have 1 unit increase, the price remains constant at P, so the change in revenue is 1 times P, which is P, so marginal revenue is equal to P. On the other hand, a monopolist has a downward sloping demand curve, and there is its revenue associated with that price quantity combination. If the monopolist lowers the price, make sure you realize that 2 things occur. C is the area of lost revenue due to the fact that the price is lowered, but the monopolist also picks up revenue because of the fact that output is increasing. So when the price falls, output increases. So when prices fall, that's causing total revenue to decrease, but the increase in output is going to cause total revenue to increase. So it all depends upon the relationship or the responsiveness of the demand curve to changes in price with respect to quantity to determine whether or not the marginal revenue is positive or whether it's negative. So make sure you're comfortable with that. That's one of the reasons why I go over perfect competition relative to monopoly in such detail, is if you understand perfect competition and why the demand curve, a firm in a perfectly competitive marketplace faces a demand curve that's horizontal, it's important to be able to contrast the monopoly where the demand curve is downward sloping. So realize that because of the fact that you have a downward sloping demand curve, the marginal revenue curve is inside of the demand curve. So let me actually draw this for you. So here we have a demand curve, and this demand curve represents where price, or this inverse demand curve, is where price is equal to 24 minus Q. So for example, if I wanted to know where this point is, I would just substitute in 0. So what's the price at a quantity of 0? It's going to be equal to 24. And at a price of 0, what is this going to be? It's going to be also equal to 24. The marginal revenue curve is going to be inside of the demand curve, and it's going to be equal to, P is equal to 24 minus 2Q. So make sure you realize this. This is the key distinction that a lot of students get confused with between perfect competition and monopoly. In monopoly, you have a downward sloping demand curve, and the marginal revenue curve is inside of that. The simplest way to realize that is if you have this inverse demand function. So here's your demand function here. If it's linear, just multiply. If, for example, we have 24 minus Q is equal to price, just multiply by 2 in front of Q, and that will give you your new marginal revenue curve. So we have P is equal to 24 minus 2Q. If you want, you can take a look at the video I posted on how to calculate a derivative and how if you go from total revenue to get marginal revenue. Realize that where this intersects, marginal revenue intersects quantity, where the x-axis, that's where the price elasticity of demand is equal to -1. All right, we went over this previously when we talked about elasticity. So realize that the area above that, for prices above this point here, that the price elasticity is elastic. All right, so the price elasticity is less than -1. And if it's in this region down here, it is inelastic. Realize this here. This is a convenient formula that you should probably keep handy, or I would even recommend memorizing this, that marginal revenue is equal to price times, in brackets, 1 plus 1 over the price elasticity of demand. So realize that for a monopolist, marginal revenue is a function of price and the price elasticity. So here's an example just to show you that relationship here. We have our demand curve. So the left-hand parts here, Q and P, are the demand schedule. Marginal revenue is equal to P equals 24 minus 2Q. So we have Q. We can substitute Q in here to get marginal revenue all the way down, which we've done. So if we put 0 in here, marginal revenue is equal to 24. If we put 1 in for Q, it's 24 minus 2, which is 22. If we place 2 in for Q, we have 24 minus 4, which is 20, etc., all the way down. Okay? So realize that you're going to have a section where if you have a downward sloping linear demand curve, that you're going to have a portion of it where marginal revenue is positive and a portion where marginal revenue is negative. And then from there, we can also calculate the price elasticity of demand, which is negative the price over Q. And we can do that. And we have P, negative P over 0, which is negative infinity. And you can go through all those calculations. So this is just illustrating to you, one, that you have a downward sloping demand curve, that the price elasticity varies depending upon where you are in the demand curve, and also illustrating that the marginal revenue curve is going to be inside your demand curve. So what does a monopolist do? Does it choose P or Q? It's doing both at the same time, that whenever it adjusts price or it adjusts output, it is also adjusting output and is also adjusting price. So realize that the monopolist is constrained by the market demand. Oftentimes I hear students saying, well, monopolists can charge whatever they want. No, they can't charge whatever they want. They can only charge what the market will bear. So they are constrained by the market demand curve, and anytime they increase output, price has to fall, or every time they increase the price, their quantity produced is going to decrease. So realize that what we're going to do for the remainder of this chapter is that the monopolist is going to be setting quantity, and then from that quantity, the price in the marketplace is going to be determined by the demand curve. So let's take a look at here's a graphical approach. We have our demand curve and we have our marginal revenue curve. All right. Roughly, I tell students that the marginal revenue curve should intersect the halfway point between the origin and where the demand curve intersects the x-axis. So this is roughly a halfway point here. So we have our downward sloping demand curve, the associated marginal revenue curve. I'm going to draw in average cost, average variable cost, and marginal cost. So profit maximization, as always, occurs where marginal revenue is equal to marginal cost. So where marginal cost and marginal revenue intersect one another, that will give us our profit maximizing output level. If we go from that profit maximizing output level up until we hit the demand curve, that will yield the profit maximizing price, and the area above the average cost curve here, this is going to be the profit margin between there, profits between there and the demand curve. If you want to think about it, this area plus the white area down in here, this white box down here, is going to be total revenue. That is going to be P times Q So this yellow area and the white box at the bottom is going to be total revenue, and total cost is just going to be average total cost multiplied by Q. So if I go from Q pi up to average total cost and across, the white section down in here is going to be total cost. So if I take total revenue and subtract total cost, that gives us the profits for the monopolist. The shutdown decision is exactly the same as in perfect competition. If price is less than average variable cost, you shut down, and that's for the short run. And in the long run, if price is below average cost, then you shut down. Let's do this mathematically. So you might be given a cost function. So total cost is equal to Q squared plus 12. If you take the derivative of that, you end up with 2Q. You can review the video I have on taking a derivative. So if you take the derivative, you're measuring the change of this with respect, change in total cost with respect to Q. All right, so this does not change, so this is equal to 0, and this is just 2 multiplied by Q and taking the exponent here, to the negative 1 power. So we end up with 2Q to the first power, and we drop the 1 off of there. So marginal cost is equal to 2Q. We are given our demand curve, so here's our demand function. Price is equal to 24 minus Q. And we also know that total revenue is equal to P times Q. So in order to do this, total revenue is P times Q. So I take P and multiply by Q. So 24 minus Q multiplied by Q. I multiply that through, and total revenue is equal to 24Q minus Q squared. I take the derivative of that. Okay, so here it would be, this is Q to the first power. I multiply 24 by that. And since this is to the first power, I subtract 1 off of there. So this is Q to the 0 power, which is equal to 1. So it's 24 multiplied by 1 is equal to 24. And this, I bring this 2 out front. So I'm multiplying by the exponent and subtracting 1 off that exponent. So I end up with 2Q to the first power, which is equal to 2Q. So I have marginal cost and I have marginal revenue. I can set them equal to one another. So 24 minus 2Q is equal to 2Q. That is equivalent to 24. 24 equals 4Q. I divide both sides by 4, and I get the profit maximizing output level is equal to 6. So I have the demand function, and all I have to do is place Q into the demand function. So it's 24 minus Q, 24 minus 6. So the price is equal to 18. So to get total revenue, I just multiply P times Q. 6 times 8 gives me a total revenue of 108. My output is equal to 6. I can place 6 into the cost function. So I have 6 squared plus 12. So it's 36 plus 12 is equal to 48. So I could take total revenue and subtract total cost from that, 108 minus 48. And the profits of this firm are going to be equal to 60. Also realize that one of the phenomena that we're going to see here is that the monopolist does not have a supply curve. Remember, in perfect competition, what occurred with that as the price increased, we just mapped out along the marginal cost curve above average variable cost, and that became our short-run supply curve. The same thing does not hold in monopoly. So I want you to be aware of that. So for example, if I were to assume that supply was equal to marginal cost, whenever demand shifts, I'm going to get a distinct price, another price quantity combination. So I'm going to have P1 and Q1, and then I'm going to have P2 and Q2. So whenever this demand curve is shifting, I'm just going to be following along the marginal cost curve, which will map out what the supply curve is going to be for this particular firm operating in a perfectly competitive marketplace. If we do the same thing in a monopoly, take a look that because we have a demand curve and a marginal revenue curve that's inside of that, we end up with a distinctly different result. So I'm going to draw in a new demand curve and a new marginal revenue curve. And from that, you can see that the way I particularly drew this, that we don't have distinct price quantity combinations. We get the same quantity for P1 and for P2, and that's because of the fact that we have a distinct marginal revenue curve that's distinct from the particular demand curve.